Welcome back to my weekly Lunch and Learns. We took a week off last week. Sorry I missed you, but I'll be going strong every Wednesday in May moving forward. Today we're going to talk about space. Figured let's do a big concept that we can try and wrap our head around. It's really easy to kind of go down the rabbit hole and focus on a different topic. We're going to jump around a lot today and talk about different aspects of space and try and understand exactly what the heck it is, what it means, and what we know and what we don't know. So first off, we have to start with Neil deGrasse Tyson. He is our own personal astrophysicist, as he likes to introduce himself. He does have a book, Astrophysics for People in a Hurry. He says the universe is under no obligation to make sense to you, but we're going to try and make sense of it anyway. And if you're interested in his book, it's been adapted for younger readers, featuring dozens of color photos, infographics, and explanations of the trickiest concepts. That's what I'm interested in. Just dumb it down for me, make it as simple as possible. I don't need a textbook. Give me a kid's book. So first off, welcome. Space is complicated and it's big, and there's still a lot that we don't know, and there's a lot that we do know. Some of the things we think we know: space is always expanding, there's 9 planets in our solar system, and Earth is the only planet with life on it, right? Well, maybe not. It turns out there's a ton that we just don't know, but there are things that we think we know. Since its discovery in 1930, Pluto has caused much discussion. Is it a planet or not? It's smaller than Earth's moon, and although dense and rocky like other planets, its orbit crosses over Neptune's orbit of our sun. So it was always kind of just a tricky outlier. However, on August 24th, 2006, the IAU revoked Pluto's planetary status. Now it's referred to as a dwarf planet, and all the Pluto lovers were very upset. So, sorry Pluto, but now Earth is officially one of 8 planets in our solar system. Now, what's the difference between a solar system and a galaxy? Great question. Glad you asked. A solar system contains objects that directly or indirectly orbit the same star. In our solar system, Earth and the other 7 planets orbit the sun, and the various moons orbit those corresponding planets. A galaxy is a system with billions of stars. Now, the universe is absolutely huge. It's really difficult to wrap your mind around it, but top left, you can see the Earth. Then the next picture over, you can see our solar system, and a tiny little red font, you can see it says Earth. Then you have our solar interstellar neighborhood, the Milky Way galaxy, local galactic group, Virgo supercluster, local superclusters, and then the observable universe. So it's absolutely enormous. There's no real way to fully grasp just how big our universe is. But it is 13.7 billion years old, so that means our universe is at least 13.7 billion light years wide. And experts believe that that size is probably even 30 times bigger than that. Again, can't really wrap your head around how big. Now let's get into some key concepts, terms, questions. We're going to jump around a bit, but we really want to try and understand what we can about the universe and space in general. Does space have a smell? Astronauts have reported yes, that if they're doing work on the International Space Station and they come in, their spacesuits have like a burned or fried smell of either steak or metal. So that's pretty interesting. Then you'll hear speed of light kind of thrown around a lot. It's the most famous constant. No matter how fast you're able to travel, you cannot go faster than the speed of light. That's just the top of the line. It's about 186,000 miles per second, or 671 million miles per hour. As a frame of reference, the fastest rocket that we've ever launched in 2006, and it only traveled 36,000 miles per hour, which again, you're cooking when you're going that fast, but you're not going nearly close to the speed of light. And you'll hear the term light year, but what exactly does that mean? A light year is the distance that light travels in one Earth year. How far is that? It travels about 6 trillion miles. So if you're going to travel at the speed of light and go from Earth to the moon, it would take 1.3 light seconds. To the sun, 8.3 minutes, and then so on. What that means is, if you're looking at the Big Dipper, you're actually looking back in time, which is a pretty bizarre thing to think about. The light we see from the closest star is 78 light years away. That means the light left that star in 1942. So if that star you're looking at were to somehow explode this second, we wouldn't see it until 2096. Big Bang Theory. Yes, it's a TV show. It's also our main theory for how the universe began and made the stars and galaxies that we see today. The idea is that the universe began as a very hot, small, and dense superforce with no stars, atoms, form, or structure. All elements and particles that are in our universe formed after that explosion. So it's pretty crazy that everything that we know today had to come from that Big Bang. The timeline kind of goes like this. For the first 380,000 years, the universe was far too hot for light to shine. Then matter cooled enough for atoms to form, and the universe plunged into darkness since no stars had formed yet. Then about 400 million years after the Big Bang, the first stars and galaxies were created. A little after 9 billion years after the Big Bang, our solar system was born. Long time. Some important things to note. It wasn't an explosion in what you and I envision. When you hear Big Bang, we have this idea of a giant explosion. But the universe did not expand into space because space did not exist before the universe. I know, it's hard to wrap your head around. It's better to think of the Big Bang as the simultaneous appearance of space everywhere in the universe. So it kind of just magically happened. The universe has not expanded from any one spot since the Big Bang, or space itself has been stretching and carrying matter with it. Now, a good question to ask is, okay, what is the universe expanding into? If it's expanding, it's got to go into something, right? If you blow up a balloon, it's expanding into the air around it. There's the balloon, and then there's everything else outside of the balloon. But if the universe is all there is, how can it be expanding into nothing? Yeah, well, that depends on who you ask and what they believe. If the universe is infinite, then it isn't expanding into anything. Every region of the universe is being stretched, but the overall size of the universe doesn't change. If the universe has a finite size, then we really don't know what it's expanding into. And that's where multiverse theories come into play. So if you haven't had your morning coffee, you might want to. The idea is if space-time stretches out to infinity, then everything in our universe is bound to repeat at some point. That means if you look far enough, you'd find another version of you, and in theory, infinite versions of you. Multiverses would be a giant patchwork quilt of universes all existing next to one another. Yeah, this is really kind of out there. We know now that the universe is flat. And we know the universe is flat because there must be parallel lines that never intersect. So if you remember from your geometry class, two parallel lines never intersect. For instance, a cylinder shape is flat because parallel lines stay parallel, and that could very well be the shape of our universe, but we don't know. There are 18 potential shapes to our universe. Depending on what the shape is, could determine if our universe is infinite and will expand forever, or if it will eventually stop expanding and start collapsing in on itself. Not only is our universe expanding, but its expansion is accelerating. The Hubble Space Telescope found that it's expanding much faster than we previously thought. The Hubble constant is the unit of measurement used to describe the expansion of our universe. Another term you'll hear is redshift and blueshift. Visible light is a spectrum of colors, like a prism. When an object moves away from us, the light is shifted to the red end of the spectrum because the wavelengths get longer. If an object is moving closer, the light moves to the blue end of the spectrum as the wavelengths get shorter. Because observed galaxies appear red, we know that means they must be moving away from us. And because they're moving away from us, we know our universe is expanding. So that's kind of the simplest way to explain how we know the universe is expanding, just based on light. Gravity, most of us are pretty familiar. Although the laws of gravity are very different here on Earth than they are in space, the laws of physics still are the same. Newton's law of gravity directs the moon in its orbit around Earth, guides planets, asteroids, and comets in their orbits around the sun, and it keeps hundreds of billions of stars in orbit within our Milky Way galaxy. Now, it sounds pretty simple. We understand that big things in space have gravity, and so we have things that revolve around it, like the moon and our Earth, for instance. And we know a lot about matter, energy, and our universe in general, but we thought that until we discovered that we can't see, touch, or taste the source of 85% of the gravity we measure in the universe. It turns out we only really understand about 4% of what the universe is made of. Until about 30 years ago, astronomers thought the universe was made of, quote, normal matter. How do we know dark matter exists? How do you know that there's something out there if you can't see, touch, or taste it? Well, gravity helps explain that. Dark matter remains completely undetected except for its gravitational pull on matter that we can see. Ordinary matter has gravity and interacts with light, but dark matter has gravity and does not interact with light, our matter, or energy in any known way. It also acts in the opposite direction of gravity, forcing the universe to expand faster than it otherwise would. Across the universe, cosmic dark matter has about 6 times that total gravity of all the visible matter. This missing mass that is causing the gravitational forces we observe is what we have labeled dark matter. It may not be matter at all, it's just kind of the name we have put for it. But it is something that has yet to be discovered and explained. This video, I think, though, on YouTube does a pretty good job explaining kind of what it is, even though, again, no one really knows what to call it or what exactly it is. So we're going to watch part of this video.
Matter as we know it. Atoms, stars and galaxies, planets and trees, rocks and dust. This matter accounts for less than 5% of the known universe. About 25% is dark matter and 70% dark energy, both of which are invisible. This is kind of strange because it suggests that everything we experience is really only a tiny fraction of reality. But it gets worse. We have no clue what dark matter and energy are or how they work. We are pretty sure they exist though. So, what do we know? Dark matter is the stuff that makes it possible for galaxies to exist. When we calculated why the universe is structured the way it is, it quickly became clear that there's just not enough normal matter. The gravity of the visible matter is not strong enough to form galaxies and complex structures. Stars would more likely be scattered all over the place and not form galaxies. So we know there is something else inside and around them. Something that doesn't emit or reflect light. Something dark. But besides being able to calculate the existence of dark matter, we can see it, kind of. Places with a high concentration of dark matter bend light passing nearby, so we know there's something there that interacts with gravity. Right now, we have more ideas about what dark energy is not than what it is. We know dark matter is not just clouds of normal matter without stars, because it would emit particles we could detect. Dark matter is not antimatter, because antimatter produces unique gamma rays when it reacts with normal matter. Dark matter is also not made up of black holes, very compact objects that violently affect their surroundings, while dark matter seems to be scattered all over the place. Basically, we only know 3 things for sure. 1, something is out there. 2, it interacts with gravity. 3, there is a lot of it.
So that's not a lot of information. Basically, we know some things, but we know that we don't know a lot. Great. Bottom line, on moons and planets, dark matter and energy does not exist, but we do need it to explain the motions of stars around the center of the galaxy. What we know is that the matter we have come to love in our universe only accounts for a small portion of a vast universe that looks like nothing. Okay. Milky Way, many people have heard of it. It's candy bar. It's also the galaxy that contains our solar system. It's named for the band of stars that streak across the night sky. It's estimated to contain 200 billion stars and at least 100 billion planets, and it might have just gotten bigger. It's obviously tricky to measure a galaxy we're in, but a new study suggests that stars at the edge are about twice as far away from the center as we previously thought, so 100,000 light years in radius. And here's a way to wrap your head around how big our universe is. If the Milky Way was the size of a cup of coffee, the visible universe would be a sphere about 30 miles in radius. Yikes. Black holes are something that we have talked about. It's a place in space where gravity pulls so much that even light can't get out. They form from massive stars collapsing in on themselves at the end of their life cycle. They can continue to grow by absorbing mass from its surroundings. The gravity is so strong because matter has been squeezed into a tiny space. Since no light can get out, they're invisible and extremely difficult to find, but gravitational waves help. Gravitational waves are sometimes called ripples in space-time. Einstein described their characteristics in his theory of general relativity, but they were only detected for the first time in 2015, just days after the first laser detector was turned on. We have observed 4 gravitational waves total, the most recent caused by the merging of 2 spinning black holes about 2 billion years ago. Scientists are fairly sure that nearly every galaxy has a supermassive black hole at its center. The Milky Way's black hole is called Sagittarius A, and it is 4 million times the mass of the Sun. According to a new study, it is surrounded by about 10,000 other black holes. Now, the Event Horizon Telescope is a network of around 10 telescopes all trying to take a picture of Sagittarius A by creating one combined image. And the goal is to take a picture of a black hole. And you might be saying, well, Jim, didn't we do this? Why, yes, we did. Accomplishing what was previously thought to be impossible, a team of international astronomers captured an image of a black hole's silhouette in April of 2017. Weighing around 6.5 billion times the mass of our Sun, the supermassive black hole is 55 million light years away from Earth. But that is the silhouette and the image that we were able to capture. Now, things can change really quickly. The last few years alone have changed how we view the universe and what we think might be possible. Take the discovery of gravitational waves. 130 million years ago, 2 neutron stars started revolving around one another, getting closer and closer until they finally collided. The waves from that collision traveled at the speed of light in all directions, and it didn't reach Earth until August 17, 2017. The Hubble telescope has helped us understand a lot. Launched on April 24, 1990, the Hubble Space Telescope travels at about 5 miles per second and has traveled more than 4 billion miles in its lifetime, about 340 miles above Earth. Because Hubble orbits above Earth's atmosphere, it has a much better view of the universe than telescopes at ground level. It doesn't have to interact with light radiation or the light pollution that we get here. Hubble has made more than 1.3 million observations and helped scientists estimate the age of the universe to be about 14 billion years old. It has detected black holes and played a key role in the discovery of dark energy, which again, that mysterious force that causes the universe to expand faster and faster. In November 2017, astronomers found 72 potential galaxies just hiding in plain sight from data obtained in 2004. So we're even going back to old data and finding new things. Because of how enormous the universe is, the odds that there is life elsewhere is very likely. Currently, there are over 3,000 confirmed planets, although we estimate the Milky Way alone contains at least 100 billion planets, and there are an estimated 100 billion galaxies in our universe, and that's likely to increase to 200 billion as telescope technology improves. So I know most of you are probably thinking, all right, well then where is the life out there? Well, the Drake equation allows us to estimate how many alien civilizations might exist in just the Milky Way alone. With basic statistics, the equation suggests that there are potentially thousands and even millions of alien civilizations out there. So then you've heard perhaps this Fermi paradox. Where are all the aliens? Physicist Enrico Fermi asked this very question to his colleagues, and this is what has come to be known as the Fermi paradox. Well, you can use an ocean analogy. Part of the problem is we're looking for alien life by sending out radio signals. And if we compare space to the ocean, the amount of space we have explored is equivalent to us standing on the shore and scooping out an 8-ounce glass of water and finding no intelligent life in it. Obviously, that doesn't work. Also, what do we consider intelligent life? Dolphins? Whales? How often do we get radio signals back? There could be many, many obstacles. There are also many reasons possibly why we haven't found aliens. Could be that there aren't any out there or they've died off. Again, the universe is old, so 14 billion years old. Maybe they died off 3 billion years ago, or even more recent than that. We don't know. Could be that intelligent species lack advanced technology. Maybe space is just too big to communicate across. We may not be looking long enough or in the right place. Maybe their technology is too advanced or they don't want to be found. I don't blame them. But there might be new evidence for life on both Jupiter's icy moon Europa on the left and perhaps Mars on the right. NASA's Curiosity rover has found organic molecules preserved in 3-billion-year-old Martian bedrock, suggesting conditions back then might have been conducive to life. There are also sharp seasonal increases of methane in the Martian atmosphere. Now, most of Earth's atmospheric methane comes from animal and plant life, so scientists are getting excited. Maybe that spike could prove that there's plant or animal life. But there's no proof how this methane's formed, so more powerful spacecraft and ideally rocks returned to Earth are needed to prove whether organisms exist or have existed on Mars. Jupiter's moon Europa has long been considered one of the best spots to look for alien beings. Scientists reported in May that this was May last year, that giant jets of water are spouting more than 100 miles off Europa's surface. If confirmed, the plumes are coming from Europa's saltwater ocean. A spacecraft could simply fly through the spray, test its contents, boom. 2 missions are slated to launch in the early to mid-2020s and arrive at Jupiter around 2030 to hopefully catch molecules and measure their composition. Now, the thing that I'm most excited about in the near future regarding space is the James Webb Space Telescope. The Hubble telescope received its final upgrades and maintenance in 2009. It's expected to work into the future. But the future of what we come to understand about the universe is going to come from the James Webb Space Telescope, which will be launched, we hope, on March 21st, 2021. There have been significant delays, but we're hoping this is the final date. It's going to orbit the sun instead of Earth about 930,000 miles away. So almost 1 million miles away from Earth. Price tag is almost 10 billion and counting, but this is a really quick video about the James Webb Telescope, how it was made, and what it might be capable of.
This is your telescope, an engineering marvel, an exploration powerhouse. Use it to look back in time and explore the first galaxies that formed after the Big Bang. To peer into atmospheres of planets orbiting the stars. It's your eyepiece to the uncharted, unknown, and unimagined. This is the largest, most complex, and challenging space telescope ever constructed. It will change our understanding of the universe and our place in it. The James Webb Space Telescope. Equipped with the largest binary laser ever to be flown in space at 6.5 meters, it's more than 6 times the size of the Hubble Space Telescope primary mirror. What's 4 cutting-edge infrared instruments and cameras operate at super cold temperatures colder than the surface of Pluto. Getting this cold is done with the help of the largest sun shield ever flown. A 5-layer, tennis-court-sized sun shield that blocks heat from the sun, Earth, and the moon. Webb will be the first telescope to detect light from the most distant galaxies in the universe. These first galaxies formed about 13.5 billion years ago, only 300 or so million years after the Big Bang. Webb carries advanced technologies to tackle some of the most fundamental questions about the universe. How did the first galaxies form? Launching such a large telescope into space is an incredible engineering challenge. Fully deployed, Webb is too large to fit inside any rocket fairing. Engineers designed it to be folded, about a body, to squeeze inside the European Space Agency's 5-meter diameter Ariane 5 rocket fairing. After launch, controllers on the ground deployed Webb remotely. Deployment is an intricate ballet. For nearly 3 weeks, controllers carefully unfold the Webb. After this delicate dance, Webb's golden mirrors are precisely aligned with the motors behind each hexagon mirror segment, adjusting them to form one perfect mirror. Once the instruments are fully cooled, the exploration will begin. Webb is a technological challenge like no other, right at the efforts of thousands of people across the United States, Canada, and Europe. The James Webb Space Telescope is your telescope. Use it to explore, to challenge theories, to see sights yet unseen. It's yours to unfold the beauty and mystery in the universe and our place in it.
It's yours, guys. Let's use it. All right, some other cool things in space already. Launched in April 2018, TESS is currently orbiting Earth and will search for planets outside our solar system on its current 2-year mission, which just recently ended, but TESS is still out there. The main goal of the TESS mission is to detect small planets with bright host stars so that detailed future observations of the planets and their atmospheres can be made. As of April 18, 2020, TESS had identified 1,785 candidate exoplanets, of which 45 have been confirmed so far. Then we have Jupiter's red spot, just kind of jumping around to other things in the solar system that you may or may not have heard of. In July 2017, images from NASA's Juno spacecraft showed the red spot on Jupiter in more detail than we had ever seen before. Pretty cool. Jupiter's clouds, also very cool. Juno captured this picture from about 9,600 miles above the planet's cloud tops on May 24th, 2018. On October 19, 2017, Oumuamua, which means a messenger from afar arriving first in Hawaiian, was discovered by the University of Hawaii, becoming the first known interstellar object to pass through our solar system. Then we have a plan to get back to the moon. With the Artemis program, NASA will land the first woman and the next man on the moon by 2024, using innovative technologies to explore more of the lunar surface than ever before. The plan is to establish sustainable exploration by 2028. What does that mean? Well, they're hoping to have something on the moon like its own space station or like a structure that we can have on the moon. And then hopefully NASA wants to use what they learn on and around the moon to take the next giant leap, sending astronauts to Mars. So right now, if we want to go to Mars, we would have to go straight to Mars from Earth. That's really difficult. They're hoping we can use the moon as kind of like a launching point. So manned spaceflight to Mars in the 2030s seems to be the newest goal. But a few things must be accomplished before we can have a Mars mission, including learning more about Mars and spending that much time in space. We don't know what that does to the body. So you have astronauts that are in space for a full year. Just for your interest, it takes between 150 to 300 days to get from Earth to Mars, depending on the location of where Earth is and Mars and all of that. So if we could go from the moon to Mars, it might make things a little bit easier. One company is working with NASA to try and develop a cryosleep chamber to solve one of those issues. Who knows, maybe that would help. Since you're home, if you're looking to get some more information on space or maybe just enjoy some space-related movies, these are some that I would highly recommend. Number one is Interstellar. It came out in 2014. Earth's future has been riddled by disasters, famines, and droughts. The only way to ensure mankind's survival is finding another planet that can support life. There are many plot points in this movie based on the works of theoretical physicist Dr. Kip Thorne. It's a really cool movie if you haven't seen it. Finally, next we have Apollo 13. Many of you have probably seen it with Tom Hanks, Kevin Bacon, Bill Paxton, Gary Sinise. It's the amazing true story about trying to get the crew of Apollo 13 space mission back to Earth. It gives you everything you could want: Tom Hanks, action, and the iconic line, "Houston, we have a problem." The Martian from 2015, it's based on the book by Andy Weir. Mark Watney, played by Matt Damon, is stranded on Mars and is trying to survive alone. NASA was consulted to get aspects of space and space travel as accurately as possible. Then finally, we have Gravity, came out in 2013. It's about two astronauts, Sandra Bullock and George Clooney, working together to survive after an accident which leaves them stranded in space. And there's a shout out for Lake Zurich. She is from Lake Zurich, Illinois. Why they pick Lake Zurich, I don't know, but good for Lake Zurich, good for Sandra Bullock. And that's all I have for today. Check out our May programming. We have it listed on our website, elatownship.com/seniors. We also have it on our Facebook page. So there you can see our various programming. You can see my lunch and learns every Wednesday. And we also have the menus and everything else you can think of. If you have questions or want to sign up for anything, let us know. Otherwise, this is what we're working to accomplish for the whole month of May. If you guys have any questions, give us a call anytime. Otherwise, I'll see you next week. Take care.